Alright guys, lesson 2. We're going to look at isomers, and we're going to look at how isomers are defined. So let's start with defining what an isomer is. So this is an organic compound with the same molecular formula but a different structural formula. Right, so remember that our molecular formula is what tells us how many of something there are. So this tells how many of each element. All right, but it has a different structural formula. So the way it's laid out is a little bit different. So these isomers will have different chemical and physical properties. Okay, so that's what an isomer is. So it's the same molecular formula, but a different structural formula. And they have different chemical and physical properties. So let's look at the first thing we're going to chat about. It's going to be an alkyl group. So alkyl groups are a branch off of a parent chain. So they branch off of a parent chain. And a parent chain, just to kind of recap, I know I mentioned it a little bit in the first video. So this is the longest continuous chain of carbons. So longest continuous chain of carbons. Okay, so they have one less hydrogen, have one less hydrogen atom than an alkane formula. So remember our alkane formula, our alkanes were CnH2n plus 2. So our alkyl formula is going to be CnH2n plus 1. So let me go back real quick. So let me see if I have room for this. So if we have methane, right? I'm just going to erase this real quick. I'll rewrite it somewhere else. So if we have our alkane, methane with CH4, our alkyl group is going to be methyl, and it's going to be CH3. Right? So then we have ethane, which was C2H6. Our alkyl group is going to be ethyl, C2H5. Oh, hi, Odie. My dog just walked in. I wish you guys could see him. He looks really cute right now. Anyway, so you get the picture. As we go, we drop a hydrogen, and we change the name from ane to il, right? So we drop the ane, and we add YL. So that formula, again, was CnH2n plus 1. Okay, this goes on and on for each prefix as we go down. So let's check out our rules for naming organic compounds. So our first step, we're going to find the longest continuous chain. So find the longest continuous chain, otherwise known as the parent chain. And it doesn't have to be in a straight line. And we're going to name that chain, whether it's an alkane, an alkene, or an alkyne. That's our first step. Our next step is we're going to locate those alkyl groups. So locate alkyl groups. We're going to name the alkyl group, whether it's methyl, ethyl, butyl, propyl, so on and so forth. So we're going to name the alkyl group. And we're going to use a number to tell somebody else, to tell somebody where that is. So use number to locate alkyl group. Kind of like we had the numbers to tell us where our double or triple bonds were. Same thing with the alkyl groups. And our last one here, 3, if there are multiple alkyl groups. So if there are multiple alkyl groups, and multiple of the same alkyl group, put same in parentheses, you're going to use a prefix in front of the alkyl group. Right, so we're going to say if there's multiple alkyl groups using a prefix, or we'll actually use, so our prefix is going back to our naming, so di, tri, those prefixes. So if there are multiple alkyl groups, we're going to use a prefix in front of alkyl group. We're going to look at a couple examples. So the first example I want to look at is 3-methylpentane. So, pentane, this is our parent. So we're going to start here. So pent is 5. So we're going to have 5 carbons. All right, so let me make sure we have our periodic table. So pent, again, 5. So 5. And it ends with ANE, so we know that it's going to be our 2N plus 2, so we're going to have 12 hydrogens there. Okay. We also notice that we have a methyl group. Our methyl group, or our alkyl group, methyl, we said was CH3. And it's telling us it's in that 3rd spot. So we're going to start by building our parent chain. So we're going to have 1, 2, 3, 4, 5 carbons. Okay, so we're not going to add our hydrogens yet. This is just the parent formula for pentane. We're going to add our hydrogens at the end after we add our alkyl group, because you're going to notice it's a little bit different. So our alkyl group we said was 3. So we have 5, so 3 is going to be our central carbon. I'm going to add a line here, and I'm going to add my whole alkyl group. Right, because we said it was on the 3rd carbon. We're going to go 1, 2, 3, 4, 5. Again, the direction you label it, whether you go left to right or right to left, that doesn't matter. Okay, so now what I'm going to do is I know it's ane, I know it's single bonds. I'm just going to go in and add my hydrogens until everybody is full and happy. Right, so we want all carbons to have 4 bonds total. So this is 3-methylpentane. So if we take a look at this and we count all the carbons total, like let's look at our molecular formula. So we have 1, 2, 3, 4, 5, 6. So we really have 6 carbons. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogens. So C6H14, following our alkane naming formula, this would be hexane. So what we can talk about from here is that hexane and 3-methylpentane are isomers. Right, so they have the same molecular formula. Of C6H14, but they have different structures. They have different structural formulas. Different structural formulas. So, let's take a look at another compound. So we have 2,4 dimethylhexane. So let's start with identifying our parent chain, hexane. So hex is 6. So we're going to have 6 carbons as our central chain. So let's do this. 1, 2, 3, 4, 5, 6. Okay. Our alkyl group, methyl. We said this was CH3. Di. Remember, we said we talk about prefixes, so there's going to be 2 of these. And our locations were given to us, 2 and 4. I'm going to start counting, 9 times out of 10, I'm going to start counting my carbons from the left to the right. So this will be carbon 1, and this will be carbon 6. So my methyl groups exist on carbon 2, so here's carbon 2. I'm going to put my methyl group. And carbon 4, here's another methyl group. So that's all set, right? 2 methyl groups on 2 and 4. Now I'm going to go back in like I did before and add my central bonds. Everybody's single because it's ane. And then I'm going to add my hydrogens, right? We want to make sure all carbons have 4 bonds. Need one here. So that's our structural formula for 2,4-dimethylhexane. Let's count up all the carbons. So we have 1, 2, 3, 4, 5, 6, 7, 8. So our whole thing has 8 carbons. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 hydrogens. So based on our normal naming, C8, that's oct. So we're going to have octane, the same molecular formula as octane. So octane and 2,4-dimethylhexane are isomers. So octane is an isomer, right? Same molecular formula right here, but they have different structural formulas. Let's do another practice one. I would like for you guys to pause the video and take a minute to work on this. Again, I'm going to just talk through it so we're not wasting time. So, 2-ethyl, 3-methylhexane. So, first step, find the parent chain. Hex. Hex means 6. So, I'm going to put 6 carbons. 1, 2, 3, 4, 5, 6. Now, if you notice, I have 2 different alkyl groups. I have ethyl and I have methyl. So ethyl is going to be C2H5 and methyl again is going to be CH3. These are 2 separate alkyl groups at 2 separate locations. Ethyl is on the 2nd carbon and methyl is on the 3rd carbon. Again, my counting is going to start from the left. So let me add my carbon bonds. And I'm going to start with ethyl. I'm going to make ethyl blue so you guys can see it. So I'm going to add my ethyl to the 2nd carbon. So I'm going to do 1 carbon, 2 carbons, 1, 2, 3, 4, 5 hydrogens. So that's what an ethyl group looks like. Okay, and then we're going to go to purple for our methyl group. So 1, 2, 3. I'm going to put the methyl group on top so they don't get conflicted. The position doesn't really matter for right now. So that's our methyl group. And then we're going to go back to green and we're going to fill in all of our missing hydrogens. So 1, 2, 3, 4, 5. You need one, you need one, you need one. Odie's back. Hi, Odie. All right, so again, we'll put our H's here so you guys can see it. On the next one, I'm going to stop drawing all the extra H's just to save some time. So, if we're looking at this entire compound, I want to know what its molecular formula is. So, we're going to count our carbons. We have 1, 2, 3, 4, 5, 6 from our parent chain, 7 from our ethyl, 8, 9 from our ethyl. So, we have C9. My dog is just staring at me, but it's fine. And then H's. So, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our molecular formula This is the same as nonane. So 9 is known. So that means that 2-ethyl-3-methylhexane is an isomer of nonane. So same thing. They are different structural formulas, but the same molecular formula. And that means they have completely different chemical and physical properties. All right, I think we got a couple more just to keep practicing with. So now we have an ene. I don't know if you guys can see this right away, right off the bat. So ene, so that's going to be our double bond. So our parent, pentene. So I'm going to draw 5. 1, 2, 3, 4, 5. I have a 2 here. This 2 is telling me where my double bond is, right? So again, I'm going to start counting from the left. My double bond is going to be on the second carbon, so it's going to be between the second and third carbon. So now I'm going to go through and fill in everybody else. I have a methyl group on 3. Remember, methyl is CH3. Excuse me. Okay, so now I'm going to go to the third carbon, and I'm going to add my methyl group. And now we can go through and add the rest of our hydrogens to make sure that every single carbon has 4 bonds. Let's do a quick check. 1, 2, 3. 1, 2, or 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Oh, you need another one here. Okay, that looks good to me. So, with this guy, I know I said I wasn't going to add my H's, but I'm going to add my H's so everybody can see. So that's our structural formula for 3-methyl-2-pentene, right? So if we count up all of our carbons here, 1, 2, 3, 4, 5, 6 carbons. So we have C6, and we have H3, 4, 5, 6, 7, 8, 9, 10, 11, 12, H12. So this is an isomer of hexene because it has that double bond. We have to remember the E and E for a double bond. Okay, let's look at one more. So 2,6-dimethyl-1-heptene. This is going to be our last one for this lesson. So let's go through this one together because it looks like there's a lot going on. So we're going to look for our parent, heptene. Remember, ene is our double bond. We have our location of our double bond on the 1. We have our alkyl group, which is methyl, so CH3. We see that it says di, so that means there's 2 of them. And we have our locations, and now my dog is scratching at the floor. So if you hear that, that's what that is. So we're going to start with drawing our heptene. So hept is 7. So we're going to have 1, 2, 3, 4, 5, 6, 7. My double bond is between the first and second because I was told it was 1, so we'll put our double bond there. My methyl groups are on 2 and 6, so because I put my double bond here, and I said this was carbon 1, this is going to be carbon 2, this will be 6, 7, so on. I'm going to put my first methyl group here. Let me just erase my arrow. And I'm going to put my second methyl group here on 6 because that's where I was told they were. The reason why I mentioned that is because 2 and 6, they kind of look like mirrors of one another. That's why I said it doesn't matter which direction you count from as long as you're counting from the same direction when you're putting your double or triple bond in as well as your alkyl groups. So let's fill everybody in. Make sure everybody has 4 bonds, all of our carbons, 4, 4, 4, 4, 4, 4. So let's figure out which compound this is an isomer of. So we're going to have 7 carbons from our beginning plus 2, so we're going to have C9, and H we're going to have 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if we look at our table, known again is 9. So we're going to have known ene. Remember the ene for our double bond there. So this is an isomer of known ene. All right, guys, just like with the end of lesson 1, what I would like for you all to do is in Google Classroom, there is a worksheet posted that has a couple multiple choice questions about isomers and that are related. So please work on that before you jump into lesson 3. And just as I said with lesson 1, the notes will be posted for you guys as well. Stay well, keep up with your work, and reach out if you guys have any more questions.